This is quite a small topic, but there's often exam questions on it, so it's worth knowing what the keywords mean. It's looking at chemical reactions and what happens in terms of energy in those reactions. You've got exothermic ones, where the energy is transferred to the surroundings, and that's things like combustion, oxidation reactions, where you're adding oxygen to something, and neutralization reactions from your acid and alkalis topic. There are some uses of these that are often brought up in exam questions, like self-heating cans and hand warmers as well. A trick to help you remember it is that exothermic sounds like exit. You'd go out and exit, and exothermic reactions give out energy. They give out heat. So that means that actually if you felt an exothermic reaction or put a thermometer near it, then you would feel it getting warmer. So something like a fire, combustion, is an exothermic reaction that would give out heat. It would feel hotter as the reaction's happening. The complete opposite of this is an endothermic reaction. This is one that actually takes in energy, and the ones that we've looked at already in chemistry that we know are endothermic are things like thermal decomposition from your limestone cycle topic. You might have seen sports injury packs where you snap something inside it and it'll actually cool down the chemical in the sports injury pack so that you can apply that like an ice pack to any injuries. The endothermic one, as we said, is the opposite of your exothermic, so it takes in energy, and that means that if you felt it, it would actually feel a lot colder, or if you put a thermometer there, you'd see the temperature decreasing. If you see a sign like this with 2 arrows on it, that's something called a reversible reaction. And if a reaction is reversible, that means it can go both forwards and backwards. So you can do the reverse of it, hence reversible. If a reaction is reversible, then one way will always be endothermic and the opposite way will always be exothermic. The example that comes up really often in your exams is this one here, where you have hydrated copper sulfate turning into anhydrous copper sulfate and water. And the forwards reaction, so turning from hydrated into anhydrous, is endothermic. It takes in heat. So if you took a Bunsen burner and some copper sulfate, the blue hydrated version, the blue version with water in it, and you heated it up, what's going to happen is that water is actually going to evaporate. You might see it appearing again as condensation on the inside of your test tube. So that's your other product. You've got the white anhydrous copper sulfate, the copper sulfate without water, and you've also got the water that's appearing as condensation on the inside of the test tube. So to recap, as you heat it, your hydrated copper sulfate, the blue stuff, is going to take in that heat and it's going to turn into the anhydrous copper sulfate, the white stuff that doesn't have water in it anymore, because the water has been produced and it often appears, as we said, as condensation. Remember though, we said this is a reversible reaction, so you can go back in the other direction. So if you take your white anhydrous copper sulfate without any water in it, and you add water to it, then it'll go back to the hydrated with water blue copper sulfate. As we said, this is an example that comes up really often in an exam, so it's worth knowing the colours, and it's also worth knowing these words: hydrated with water, anhydrous, no water, you've removed the water by heating it.